Assalamualaikum warahmatullahi wabarakatuh and good morning to all examiner and my supervisor. My name is Muaz bin Shamsul Lusli with metric number 64898. My final year project under Dr. Dayang Salwani binti Awang Adni is the effect of non-sterilized Sago Frond sap on ethanol fermentation. So I will describe briefly the report of this project. Table of content. First we look at the abstract. Bioethanol demand rise nowadays because it can be used as an alternative biofuel. Our aim is to study the potential of non-sterilized Sago Frond sap as an alternative raw material for bioethanol fermentation efficiency. So we conduct the experiment with a two set of media which is non-sterilized and sterilized. The result for yeast growth profile, total glucose consumption and ethanol production justify that there is no need for the substrate to be sterilized. Fossil fuel has been depleted nowadays because of human overexploitation, so the world need a new alternative biofuel. Here is a future solution, bioethanol. Bioethanol is ethyl alcohol or C2H5OH that produced by fermentation of agrowaste and utilized by microbes, specifically yeast. The function is varied, including alcoholic beverage, transportation, chemical industry. Bioethanol has been widely used around the world, include USA, Brazil and China. Why? Because it's renewable and environmentally friendly. So we look at the basic ethanol fermentation process. As we can see in the diagram, the complex sugar that we obtain from the agrowaste will be undergo pre-treatment, where the complex sugar will break down into the simple sugar which is glucose and fermented into bioethanol by yeast. In this study, we utilize a yeast, or specifically we use a Saccharomyces cerevisiae species. This yeast have a potential to metabolize the glucose into the ethanol. And the Sago Frond sap also used in this study. Sago Frond sap basically a sap or juice or liquid that we obtain from the Sago Frond, and we extract from Sago Frond, and this sap contain a glucose that we can use as a fermentation substrate. And we also use a non-sterilized fermentation. Non-sterilized fermentation is the fermentation process without undergoing aseptic technique. It believed can be cost effective as a aseptic technique consume a major cost of the fermentation process. However, sterilized Sago Frond sap also have been used as a purpose for comparison. Now take a look at our problem statement. The first problem statement is environmental damage, where agrowaste residue, especially Sago Frond, commonly dumped in the sago palm plantation area, which lead to slow down degradation process due to high lignin content. The second problem is a high cost of aseptic fermentation production that I have been mentioned earlier. So we met an objective for our study is to determine the effect of non-sterilized Sago Frond sap on ethanol fermentation and to analyze the ethanol fermentation efficiency, glucose consumption and yeast growth profile between sterilized and non-sterilized Sago Frond sap. Material method. Before that, I want to mention that this material and method for this study was according to the Fundamental Research Grant Scheme. For this experiment, we use a simple tree material which is a Sago Frond roller press machine and commercial baker yeast. This is the overview of the method. First method is we prepare the Sago Frond sap. It begins with the Sago Frond that obtained from the Sago plantation in Payapaloh, Kota Samarhan. And the frond will be cut longitudinally and pressed with roller press machine, and the sap has been extracted and used directly for the fermentation without undergoing pre-treatment process. For the preparation of microorganism, commercial baker yeast or Saccharomyces cerevisiae has been inoculated in yeast mouth broth medium and stripped onto potato destroyed agar plate, as we can see at the picture, and incubate with the suitable condition to obtain a single colony. That single colony will be inoculated in 100 ml of sterilized sterile inoculum media that contain glucose and yeast extract, incubated, centrifuged to acquire yeast pellet, and the yeast pellet will inoculate into fermentation media that contain 200 ml of Sago Frond sap that perform triplicate with two different sap, which is a non-sterilized and sterilized. The pellet that have been inoculated into fermentation media was incubated in rotary shaker, and 10 ml of sample for each media have been collected every 4 hours, centrifuged for 10 minutes, and the pellet was dry overnight at 90 darjah Celsius. And we will determine the absorbent again dry cell weight method by using a formula at the slide. For the analytical analysis, the determination of sugar component have been performed by using the HPLC or high performance liquid chromatography, where 0.005 molar of H2SO4 has been used as a mobile phase and detected by using refractive index detector. And second one is total reducing sugar analysis, where was performed by using a DNS method where Sago sap was mixed with 2 ml of DNS reagent and heated and with boiling water and cool. And it will observe by using UV mini spectrophotometer at 575 nanometer of absorbent. The third analytical analysis is ethanol detection, where the method is same as the determination of sugar component. And the lastly is a statistical analysis, where have been using one-way ANOVA and perform using LEAD or lead technology. For the result and discussion, first result is a growth profile of Saccharomyces cerevisiae in ethanol fermentation using sterilized and non-sterilized Sago Frond sap. According to the graph, non-sterilized Sago Frond sap media produce the highest concentration with 4.98 gram per liter at 36 hours, while sterilized only 3.84 gram per liter at 42nd hour. This happens because non-sterilized culture media contain other living microorganisms other than yeast Saccharomyces cerevisiae. This will cause stress and cause contamination in non-sterilized substrate that encourage yeast to produce large amount of secondary metabolite. This secondary metabolite will enhance the yeast viability and sustainability. The second result is a glucose consumption profile in ethanol fermentation using sterilized and non-sterilized Sago Frond sap. We can look at the graph. From the graph, we have calculated that the glucose consumption percentage in non-sterilized Sago Frond sap media is lower than sterilized Sago Frond sap media with 70.62%, where sterilized with 73.68%. However, the result is consistent where both do not consume glucose completely. This is because the fermentation activity stopped due to ethanol accumulation. And also Zabet et al. In 2014 also mentioned that yeast in media need a longer time to consume glucose completely. The third result is the ethanol production profile in the ethanol fermentation using sterilized and non-sterilized Sago Frond sap. From the graph earlier, we can summarize that the maximum ethanol production in non-sterilized Sago Frond sap media is higher with 15.56 gram per liter compared to the sterilized Sago Frond sap media with only 13.5 gram per liter. Why is this happen? Is because a competition for glucose among organisms boosts a metabolite production. However, both produce below theoretical value. This happens because of two possible reasons. First, because the excessive sugar concentration surpasses the consumption capability of microbial cell during fermentation, and the second one is the maximum amount of ethanol concentration can inhibit the ethanol producing capability of Saccharomyces cerevisiae. And we look at the effect of sterilization on overall kinetic parameter of Saccharomyces cerevisiae growth. From the table, we can summarize that initial glucose for both media almost same, and glucose concentration for both media also did not completely reduce. However, non-sterilized Sago from set media show the highest biomass growth, highest biomass yield, and biomass productivity. This conclude that the yeast Saccharomyces cerevisiae growth did not affected by sterilization process. And the effect of sterilization on overall kinetic parameter of ethanol production. The table shows the initial glucose for both media also almost same. However, non-sterilized Sago from set media produce the most ethanol production even though with a low glucose consumption. However, both media produce the ethanol below a theoretical value of ethanol yield. Zabet mentioned that the longer fermentation time is required when using high amount of initial sugar concentration. This is the conclusion. From our result, we conclude that as Sago from set media unnecessarily to be sterilized. This is because the competition for glucose among organisms in non-sterilized Sago from set media boosts a metabolite production. The high concentration of ethanol produced will favor to yeast growth rather than another microorganism. This concluded SFSP can be utilized directly as ethanol fermentation medium without any modification or sterilization. For our recommendation, this experiment need to be commercialized in order to improve waste management, reduce environmental pollution, and give benefit to rural people to gain profit. Then second improvement is supplemented this media with a nitrogen source where it's potentially improve yeast growth and metabolism during fermentation. The third recommendation is lignocellulose inside Sago from set have potential to produce antibiotic. Thus, further research need to be done. This is a reference, and thank you.